scientists discovered a primeval particle. The detectors observing atoms and subatomic particles collide and create high-energy debris transform what they observe into data, a lot of data. The bulk of such data is filtered out by CERN. The LHC generates 90 petabytes of data every year, enough to fill 90,000 1-terabyte hard disks. CERN keeps it on magnetic tape in a gleaming laboratory near the French-Swiss border, like a 1960s space opera. It's too much info for a person to handle. Unsurprisingly, undiscovered riches await discovery deep beneath these storage banks. They found one such gem, X, a peculiar particle with an odd name, 3872. If they're accurate, it might represent a glimpse inside the universe's first millionth of a second following the Big Bang. The results were reported in Physical Review letters on January 19th. They've barely scraped the surface of this particle. Scientists from MIT and other institutions disagreed on the theoretical predictions. X, 3872, has been seen before, although only briefly. In 2003, scientists at the Bell experiment in Tsukuba, Japan, north of Tokyo, saw X, 3872, while smashing electrons together. A lot was lost when X, 3872, deteriorated and disappeared. Scientists believed X, 3872, may be found in quark-gluon plasma. Protons and neutrons are tiny particles found in atom nuclei, however they are made up of much smaller quarks. Quarks are bonded together by gluons, even smaller particles that operate as agents of the tiny nuclear force. They break apart and mix together into a high-energy sludge made up of quarks and gluons when the temperature is very, very high. That's QGP. It took scientists till the 21st century to build it. Heavy ion collisions have been proven to function by slamming atomic nuclei together at high speeds. A lot of data trails in quark-gluon plasma were left by experiments at the LHC smashing heavy lead atoms together. Finding X, 3872, in the LHC data jungle is like looking for a needle in a field. Wang and her colleagues developed a machine learning method. They developed an algorithm to track X, 3872, as it disintegrated into other particles. The program discovered a particle with X, 3872 mass, s 100 times larger. The findings reveal more about an ancient relic. Before molecules, atoms, or even protons or neutrons, quark-gluon plasma flooded the cosmos in the first millionths of a second. To understand what's inside a particle, Lee thinks quarks and gluons in the plasma may be employed in the future. Some scientists think X, 3872, is a tetraquark, a particle containing 4 quarks. 3 quarks make up the common protons and neutrons of subatomic physics. Tetraquark particles, on the other hand, are strange and need tremendous energy to hold together. Other tetraquarks have been seen in particle accelerators throughout the last decade. X, 3872, may also be made of mesons. These are another kind of subatomic particle composed of 2 particles, a quark and an antiquark, the quark's antimatter twin. Mesons are created when high-energy cosmic rays hit with ordinary stuff. A particle made composed of several mesons has never been observed.